Good morning, class. In the last class, okay, I want to start the class now because I want to end the class earlier. So please, okay, we start the class now. Okay, so on the Monday, last few days, you have learned how to solve a differential equation in analytical way. When you are solving separable and linear differential equation and you get the solution in a function form, right? In a function form y in terms of x. That is an actual solution. So today we will look at how to solve the first order differential equation numerically. Okay, numerically. So we will use this Euler's and Runge-Kutta method. Okay, so this is what you have learned. Okay, in the last class, you learned about this separable and linear. Okay, and then you get the exact solution. Okay, then today we will look at the numerical methods. You will learn these two methods, and what you get is just an approximation. Okay, just an approximation, and the solution is in the point form. Okay, in the point form. Okay, so why is numerical method used? Okay, numerical methods, okay, we all know that numerical methods, it gives the numerical approximation only. Okay, approximation only to the solution of the ODE. Okay, ODE. The numerical approximation is often sufficient for practical purposes. Okay, in some of the problems, we may just need to know what is the solution at a certain interval of the points. So what is the Euler's method? Okay, this Euler's method is the most basic explicit method to solve an ODE. Okay, the most basic one. And actually, today you will learn this Euler's and Runge-Kutta, right? This Euler's is actually the simplest Runge-Kutta method. This is one of the Runge-Kutta method. Okay, but the simplest one. This is the formula. Okay, this is the formula. Formula will be given in any of the assessment that involve the Euler's and Runge-Kutta. A formula will be given. So what does this means? Yi plus 1, yi. Okay, from year 1, okay, year 1 you have know what is the I plus 1 means. Yi, let's say this is the current I. This yi plus 1, it will be the next, right? The next one, the next y. So to get the next y value, we will use the previous point, the previous y, and the points xi, yi. Okay, we will use the previous point to estimate for the next point. Okay, so this is the basic idea of Euler's method. Okay, first we will start from a point. Okay, start from points. Okay, if you solve using numeric analytical way, you will get the solution as a function, and that function, let's say that function, we sketch the function and we get this curve. Okay, the actual one. Okay, the actual one. Then this is the solution curve. Let's say this is the solution curve. If we solve the same ODE using numerical way, this is what we obtain, the one red in color. Okay, so starting from the same point, we will approximate the next point by using the previous point. Okay, and how to estimate? We will estimate the slope of the curve. Okay, the slope of this curve. And I'm sorry, the slope from the ODE. Okay, the slope from the ODE. Because the first order differential equation, it contains the dy dx, right? The dy dx itself is the slope. So we can estimate the slope from there. Okay, so given the slope and the line passing through the previous point, we can estimate for the next point. Okay, and at this point, we are using the slope from the ODE and the tangent line. In short, we call this as tangent line. Okay, the tangent line that passing through this point, and it follows the dy dx, the slope from the ODE, you get this tangent line. Okay, when you get this tangent line at x2, okay, this is the point. And then again, you will find for a, not you are finding, we are not finding for the tangent line. We don't find for the tangent line, but we are estimating the next point through the tangent line. Okay, so this is the tangent line that passing through this P2, and the slope follows the dy dx from the ODE. Okay, then from this tangent line, we get this point. Okay, so as what you can see here, this is the error. Okay, let's say this is the actual point. This is the approximated point. So the difference between these 2 points is the error. And the error is getting larger, right? Because what you estimated here, you have a little bit of error, and you are estimating the next point based on this point where it contains a little bit of error. So the error will be getting larger. Okay, but still in overall, this is still represent this solution curve. Okay, but this is the actual one. This is the approximated one, but with some errors. Okay. Now we look at the basic idea. Okay, basic idea. This one I have mentioned just now. When we want to estimate this next point, okay, pi plus 1. Let's say we want to estimate this next point. We are estimating this point based on this, the previous point. Okay, the previous point. And the slope, okay, this is the tangent line. With the slope of this, okay, what is this? Okay, here. The first order differential equation, you will see the term of dy dx. So when we move all the terms to the right, we just want the dy dx on the left, then you get a function. Okay, you will have a function on the right. So this function is actually the gradient, the slope of the ODE. Okay, the slope of ODE. So now we want to obtain the tangent line with this gradient. Okay, with this gradient. So this is the dy dx. So we just substitute the point. Okay, because we want to have a tangent line with this slope that passing through the previous point. Okay, pi that passing through this point. So we substitute the I, xi, yi into here. Then you get a slope. Okay, when you get a slope and we want to form an equation of the tangent line, we use this formula, y minus the y, and then the slope, okay, mx minus x naught. Okay, if you still remember the formula, y minus y naught equals to m times x minus x naught. So the m referring to the slope, which is the dy dx. And the y naught x naught is the point that the line passing through. Okay, so we get this. Okay, then x, we want to estimate the point, next point, pi plus 1. This point is also falls on this tangent line. The next point is also falls on this tangent line. This one. This is the tangent line, and the next point falls on it. So we substitute this point into this y and x. Okay, y and x. So now we get this. And we know that xi and xi plus 1 is referring to the current x and the next x. So the x and current x and next x, the difference in between them is the step size, right? The step size. H, we represent it by H. So we can replace this by H. Okay, this one, H. Okay, and you just rearrange. We want only this on the left. Okay, this one move. Then you get this formula of the Euler's method. Okay, this is the Euler's method where we estimate the next point based on a tangent line that passing through the previous point, and the slope is based on the given ODE. Okay, this is the basic idea of the Euler's method. Okay, now we look at how to solve an ODE using Euler's method. Okay, this is the flow. First, we will sketch a timeline. Okay, so we have x0, x1, x2 up to xn. Okay, so the y the corresponding y also the same. So you have y0, y1, y2 up to yn. Okay. So first, when you are given an ODE, we will rearrange the ODE in the form of dy dx on the left. Dy dx, that's mean the y prime. We want only the dy dx on the left. The rest of the terms, we move them to the right. Then you get your fxy. And after that, we discretize the equation so that x is xi, y is yi. Okay, y is yi. Then we will compute the next term by using the given formula. This is the Euler's formula. Okay, so to get the next point, we have the first point value. We have this value. We know what is h. And we can get the f value based on this function. Okay, now we look at one example. Okay, this one. Use Euler's method to numerically, okay, see, numerically integrate this. Okay, so first of all, we want to get our dy. Okay, we want only dy dx. So this y, we move it to the right. When you move to the right, you get this. So this is your fxy. Okay, dy dx is your fxy, where it is this one. Okay. And according to the question, your x start from 0 up to 2. 0 up to 2 with a step size of 0.5. Okay, so we sketch the timeline starting from 0 up to 2 with a step size of 0.5. Okay, step size. Okay, then from the initial value given, this means x equals to 0. When x is 0, y is 1. So when x is 0, the y is 1. So you substitute the value into the timeline from the given initial value. Okay, then you get this. Okay, this one you just need to sketch time. Okay, you just need to sketch one time. Once you get your y1, you just substitute the value into the timeline. You keep update the value found into the timeline. Okay, so when you get ready with this timeline, we will start the iteration I equals to 0. Okay, I will always start from 0. Okay, so if you look at the okay, this one I want to show on the whiteboard. Yeah. The formula is okay, the formula for this one. This is the formula. So when your I start from 0, so you have y 1, right? Substitute the 0 into I. I is 0. When I is 0, 0 plus 1, you get 1. Okay, I is 0, huh? So this is 0. 0, 0, x 0, y 0. Okay, then from the timeline, what is your y0? Let's see. 1. Okay, y0 is 1. And the h step size just now is 0.5. And then your f x0 is 0, y0 is 1. Okay, just now the dy dx function fxy, your fx is this one, 3x cubed minus 7x squared plus 5x minus 1y. Okay. So to get the value of this, you substitute 0 into x, 1 into y. Okay? So when x is 0, 0, 0, 0, 1 is y is 1. So negative 1. This gives negative 1. Okay, this f values gives negative 1. So if this is negative 1 times 0 0.5, negative 0 0.5 plus 1. Okay, then you get your y1. Okay, then you get your y1. Okay, then I equals to 1. After 0, I equals to 1. So you just substitute the I, which is 1, into the formula. So you have y2 equals to y1 plus hfx1 y1. Okay, so y1, 0.5, h 0.5, x1, find from the timeline, x1 is 0.5, y1 is 0.5 as well. Okay, so you substitute this one, get this value from here, 0.5, 0.5. Okay, so you just use your calculator, substitute 0.5, 0.5, 0.5, and 0.5. Then you get the value, multiply with 0.5 plus 0.5. Then you will get the value of y2. So we repeat the process. After that, you will get I equals to 2. Okay, I equals to 2. Substitute into here, here. You get one line. Substitute all the values that you can obtain from the timeline. So basically, this Euler is simple. This formula is simple. Now back to the slide. So when you get y1 is 0.5, you update into your timeline. Then followed by I equals to 1, get your y2 value. Then you substitute into the timeline. Okay. So in the solution working, I want to see this f, and then what is the value of x, what is the value of y. Okay, this one I don't need you to write this out. This is just for explanation. Okay, how to get the value of this f from this f. Okay, so what I want is I want to see this f, and then you can use your calculator, substitute all the values into here, and then multiply plus, you get this final answer. And you just give the final answer directly. Okay, because sometimes the more you write here, maybe the higher chance for you to have cadastral mistake. Okay, so you just use your calculator. Okay, 3. Okay, just click 3 and then substitute directly. X is 0.5. Okay, once you get the value, then settle this. Okay, so you just repeat until you get this. This is the final solution. This is the final solution. So this is the solution in the point form. That means as x goes, as x increases, what is the y value, how it changes. Okay. So this is approximation to the solution curve. Okay, this is a second example, dy dt. Okay, dy dt. So that means this is your fty. Okay, fty. T from 0 up to 1 with a step size of 0.25. Okay, so you have to sketch from 0 up to 1 with the h 0.25. Okay, 0.25, 0.25, and 0.25. And the initial value when x is 0, y is 1. Okay, so here when t is 0, y is 1. When t is 0, y is 1. So you substitute the initial values into the timeline, then you can start the iteration. So I is always start from 0. Substitute I equals to 0 into the formula, you get this. So you just plug in all the values that you have. Okay, then find for the f value, okay, f0, 1. Okay, xt is 0, y is 1. Okay, then get 0.875. Okay, very simple. If you know how to use the formula, so you just repeat the process, you get the final solution. Okay, this one you need to try. Okay, let's try this one. Try number 1. Okay, next, starting from 0 up to 1 with a step size of 0.25. Okay, so 0, 0.5, 0.5, 0.75, then 1.0.
Use that.
You have y1, y2, y3, and y4. Then from the initial value given, when x is 0, y is 0. Okay, so when x is 0, y is 0. The formula is yi plus 1 equals to yi plus hf xi yi. Okay, so you can start the from I equals to 0. questions? Any questions so far?
Quay tay tiếp tục là quay anh chúng tôi thấy cái sự có cái một cha sẽ phụ trên đi sắp xài được tuổi làm này sẽ xoay đấy thì nó sự ai cũng cho tiền thì bạn sẽ ngoài ra ngoài cái cái khác thì cái gì mà cái này ngoài thì sao vậy có cái gì đó phải nó được nhiều mà sẽ anh chưa lần mà soạn được quan tâm họ sẽ được quan tâm nhiều nó không có sự bắt đầu người nó từ trước đến tất cả những mà từ từ họ lại những cái ai có sẽ quay em cái giáo sư thì有些打懂哦，打懂。我做的答案是标准答案，标准答案一条有答案。啊，老板，那个几个有没有回来？以前，我穷人家来自，哎呀，我家就一个多块钱
If that I equals to 1, sorry, I equals to 0, then when I is 0, we have y1 equals to y naught plus 8 x naught y naught. Okay, when I is 0, then your y naught is 0. Y naught is 0. Your h given 0.25. Okay, then to write this out, f, what are the values? X naught, y naught. Okay, x naught, y naught, 0, 0. Okay, then use your calculator. 0, 0. Where is it? Here. This one. dy dx. Maybe your fxy. dy dx is fxy. Where fxy is this one. So when x is 0, y is 0, 0, 0, you get -1. -1 times this, -0.5, because you plus 0. Okay, so once you get a 1, 1, put it back here. Okay, then you repeat the process, I equals to 1. When I equals to 1, you have 1 plus 1. So y2. I equals to 1, so y1 plus h and 1, 1. Okay. Then y1 is -0.25 plus h is 0.25, x1, y1. So x1, y1. Okay. Then substitute these two values into your x and y. 0.25, -0.25. So y2, you should get -0.7656.
Yes.
Then you substitute into your timeline. Have you done this too? Okay, then I equals to 2.
Yeah.
Okay, repeat the process.
而且那时候只有零卡的白色的颜色，现在黄就黄的零卡二，要零卡二，
To 2. When I equals to 2, you have y3. Zero point 5 and y2. Okay. 1.201. Then I 3. line 4. This one substitute back into the timeline. Line 3 plus h x3 line 3. It's line 3. 0.25 per k. X3 minus 3, x3 minus 3. Put the value back into the timeline. So this is the final solution, okay, the final one. But you need to show your working. And I want to see this. I want to see the f. What are the values of x and y? Okay, any questions? So mine is
是一个参数表，不要同意它表的看这个也所以是我 smart， 我明码，
The value that you get from your calculator, multiply this one, and then you have to sum up with this minus 0.5. Okay, then you get this. Okay, this one. Any more question for number one? Okay, if no, we look at question number 2. Or then number 2, your I starting x from 0 up to 2 pi. So from 0 up to 2 pi with a step size of pi over 2. So 0 plus pi over 2, and then plus another pi over 2, plus again pi over 2, and you get 2 pi's. Okay, then your y naught, you have y naught, y1, y2, y3, and y4. So according to the initial value given, when x is 0, y is 1. Okay, when x is 0, your y is 1. Okay, then start from the iteration I equals to 0. Repeat the process. I equals to 0. 0 plus 1, y1 equals to y0. Okay, I is 0, so x0, y0. Y naught is 1. H is pi over 2. X naught, y naught, 1. Okay, so use your calculator. Okay, this one, when you see the trigonometric function and the angle value, you don't see the degree sign, right? There's no degree sign, the symbol of degree. That means this is in radian. The calculator must be in the mode of radian. Okay, and for this one, sine x squared, for this sine x squared, some of the calculator, because there are different modes of different models of calculator. Some of the calculators, if you key in something like this, it is equals to sine x squared. Some of the calculator, you have to key in something like this. Different model, different way in the value. So you have to know how to key in for your calculator. Okay. So this one, 0, 1. Okay, this one we don't need. Okay, because when x is 0, y is 1. X is 0, sine 0, we know that this is 0. Okay, sine 0 is 0. Okay, and minus 0 is 1. So this value gives 1. Okay, 1. That means 1 plus pi over 2. We get 2.5708. Then I equals to 1, you have y2 equals to y1. Okay, I equals to 2. So you have, sorry, I equals to 1. 1 plus 1 is 2. I is 1. I is 1, so x1, y1. So, so we substitute this back into the timeline 2.5708. So 2.5708 plus 5 over 2. X1 by 1. X1. Y1. Okay, so just use your calculator, you try. Try. Let's see whether you get this 3.1610. Okay, this one is this is actually not equals to if you write manually, not equals to. Okay, whoever signs all your attendance, they want to be attendance.
This is
The one with pi, you do not know how to key into the calculator. Okay, ignore the pi. Okay, without the pi, this is actually 1 over 2, right? 1 over 2. So 0 plus 1 over 2 is 1 over 2. Then you put back the pi. 1 over 2 plus 1 over 2 is 1 pi. Okay, 1 plus 1 over 2 is 3 over 2 pi. 3 over 2 plus 1 over 2 is 2, and then pi. Okay, when I is 2, so y and 3. Y 2.
It's also
2 y 2. You are able to get the two values correctly. That's when you know how to use a formula. And this two y value.
I have no more.我可以装送人，就我说送到我给送你。 床上没有送到床上的机会，床上跟那个女生的关系很大。啦，那节目我在做出来的节目，也不是往节目讲事情，一般真的就是很喜欢。
Okay.
Okay.
So just put all the values back here. Okay, done. Okay.
这个吹外面，吹就代表那个是世界的蛮多事情的，哪里可以的。你的吹方面的话，你的排吹和方面方式排吹或是你的那个另外几句话，讲一下就是不是的，不是对。我讲的是对呀，那个是理论的说法。不需要这样，因为不代表是排斥对方，它是六方。
Okay. Different calculator has different ways to key in, right? So for to be safe, okay, to play safe, okay, you can calculate this value first. Okay, for example, this one, x is pi over 2. So you calculate pi over 2 square first. Then only you sign the answer. Sign the answer. Once you get the answer, okay, times -1 and then +1. This is the safe, the most safe method. Because I do not know your calculator should be sine pi over 2 square or sine pi over 2 square. Either one. Okay. Some calculator, you have to follow this. Some calculator, you have to follow this. So the place that, okay, you just calculate the value first. Okay. Or you try to check it out your calculator. It should be this one or this one. Otherwise, compute the x pi over 2 square first. Pi over 2 square, get the value, and then sign the value. Then multiply the negative 1, then only you plus 1.
我在打，我一个配合，我才就是他让他这个就是去年如果应该是我这个打，就那时候整个就用后面买掉。
Okay, any more questions? Okay, any more questions for Euler? We look at the second method. Second order Runge-Kutta method. Okay, second order. This second order is for this method, not about the order of the differential equation that you are going to solve. Okay, just now the Euler's method, okay, that is solving first order differential equation. Now this second order Runge-Kutta method is also used to solve first order differential equation. Okay, actually you can solve second order ODE, but in this course you are just learn on how to solve first order ODE using this RK2. Okay, so this second order is for the method, not for the ODE. Yeah? The ODE still in first order. Okay, so for this RK2, these two persons, okay, they introduce the second order method where the formula is this one. Okay, and actually the formula is this one. Okay, this is the formula, but this formula satisfies these three equations. Okay, in general, the value of A2, okay, the value of A2 here, here, and here can be assumed as three different values. Okay, let's say we start from the first one. If A2 is assumed as half, okay, if A2 is half, that means A1 is half. P1 is 1. Q11 is 1, right? So you substitute this A1, P1, Q11 into here. A1, A2, P1, Q11, you will get one set of formula. And that set of formula is for Hume's method. So if your A2 is 1, okay, if your A2 is 1, that means A1 is 0. P1 is half, Q11 is half. So when you substitute these four values into this set of formula, okay, the new formula is for midpoint method. Okay, midpoint method. And if your A2 is 2/3, it will form the Ralston's method. Okay, so among these three methods, in general, Ralston's method, it gives the best, a better approximation. Okay, a better approximation. So we will use only the Ralston's method. Okay, we will use only the Ralston's method. Okay, these are what I explained just now. Okay, when A is half, you get these three values, then you get this set of formula. This is known as Hume's method. Okay, you have Hume's method, you have midpoint, you have Ralston's method. So we will use this formula. Okay, we will use this formula to estimate for the next point. So if you look at this formula, to get the next y, we need K1 and K2. So you need to find the K1 and K2 before you get the next y value. So for every iteration, you have to find K1 and K2 first. Then you get the next y. Okay, we look at the first example. This is your ODE, first order ODE. Okay, so we move the negative y to the right hand side. So you have y minus x squared. Okay, your dy dx is y minus x squared. So y minus x squared is your fxy. Okay, fxy. So x from 0 to 2 with a step size of 0.5. Okay, 0 up to 2 with a step size of 0.5. Okay. The Euler's method and RK2 method, basically the procedure is the same. The only difference is on the formula. Okay. So the initial value given x is 0, y is also 0. So when x is 0, y is 0. Okay, then we will start to get this. Okay, this one. All right. Okay, so this is the formula. More with the yeah. Y1 equals to yi plus k1 over 3 k1, 2 over 3 k2 and h. So you need to find for the k1 first and k2. So this is the formula. And let's say we use the example just now. Example now is y minus x2. The dy dx, that means fxy is y minus x squared. And y minus x squared. And x0, y0 is 0, 0. Next one is 0.5. Okay, 0.5. So we want to find for y1. Okay. Now we will start from I equals to 0. Okay, I equals to 0. Find for the k1 first. So your k1 will be f x naught y naught. Okay, x naught y naught. So what is x naught y naught? 0, 0. Okay, 0, 0. That means x0, y0. x0, y0, 0. Okay, then find for k2. Find for k2. Okay, I is 0. So x0 plus 3 over 4h. y0 plus 3 over 4 k1h. Okay, this one, you can use your calculator directly to get the two values. Okay, so use your calculator. Okay, x naught is 0. So 0 plus 3 over 4 times 0.5. Okay, then you will get 0.375. Okay, you don't have to write substitute the x0 is 0 and then 0 plus 3 or 4 h is 0.5. No need. Okay, you can go straight to get the value directly from your calculator based on this one. Okay, K1 is 0. See, K1 is 0. That means this one is 0. You have Y naught. Y naught is 0. Then XY. XY. So you get negative 0.14. Negative 0.1406. Okay, now you have got the K1 and K2, then you can proceed to get the next Y. Okay, next Y, let's say I write it here. We want to find for Y1, right? Now I is 0. I is 0, so Y1. Y1 equals to Y0 plus K1 over 3. Your K1 is 0. K2 is negative 0.1406. And then close the bracket, 0.5. Okay, then use the calculator, solve this plus Y0. Okay. Then you get negative 0.04. 0469. Okay, so negative 0.0469. Then repeat the process I equals to 1. So meaning that for every iteration, you have to find for K1, K2 because you need them here for the next one. Okay? No? Yes. Every iteration you need to find for K1 and K2 before you find for the next Y, because in this formula you need K1 and K2. Without K1, K2, you can't get to proceed to find for the next Y. Okay? Any more questions? Okay, now we try the exercise. Okay? Try the exercise because the steps of this is the same with the Eulers. Okay, you need to fill up all the Y. Okay, we go straight to the exercise. Okay, 5 minutes. Sketch the timeline. X from 0 up to 3 is step time of 1. That means 0, 1, 2, 3. 0, 0 up to 3, so 0 with the left side of 1. 0 plus 1, 1 plus 1, 2 plus 1 again, 3. So stop here. Initial value when x is 0, y is 1. Okay, when x is 0, so y is 1. Start the iteration I equals to 0, find for the k1. K1, xi, yi, I is 0, so x 0, y 0. Oh, you need to write out xy first. Your fxy is sine x minus 1. Okay, your fxy is dy dx. Okay. 0, 1, 0, 1. That means sine 0 is 0, 0 minus 1, negative 1. So you need to find out what are the values of x and y first. Y 1. Then times 8. 3 over 4 k1 is questions? Okay, then continue with I equals to 1. Okay, when I equals to 1, x1 y1, x1 y1. Okay, I is 1. You have to try, okay, try to check whether you get the exact answer. Okay, I is 1, that means you find for y2. Calculate on your one and check its line.
我对我跟你讲，类似的，那你跟这个得啦，因为也是我会的，得啦可以好用，因为我好看到这个，没有，我的信号。6号是面向是北京，我的5号是面向就是可能现在是面向水那一项的六所不会去那问题大概是个什么走那种。在为你这个星期六的表演就是光靠你的领导，大家。我没有，我还是假装。这样子的东西，跟这样说不要玩。没有呀，我这个没有给我看，没有给我。是给卖一个。都自己那个是那种还是一个说的对对可以这个完全高配可能知道的人，
Okay, any questions? Okay, basically this one, if you manage to get the correct answer until this 0.9930, then I believe that you have understand how to work this out. Okay, this one you can try. You can try. If you didn't get it, you can try at home. Okay, for question number 2. Okay, question number 2. Today I have to end the class earlier, so I give you the answer for K1, K2, and line for each of the iteration for number 2. Try at home, okay?
Okay.
Okay. Okay. After you work this, because according to the question, if you read on the question number 2, given the exact solution as y equals to x minus ex. Okay. Given this is exact solution, find the true percent relative error of y2. True percent relative error of y2. Okay, which one is y2? Which one is y2? If you sketch the timeline, okay, if you sketch the timeline, you see your x starting from 0 up to 2, right? 0 with 0.5, so x2 is 1, x3 is 1.5, and x4 is 2.0. Okay, so you have y0, y1, y2, y3, and y4. Which one is y2? Which point? 1, 2, 3, 4, 5. Huh? This one. This means when x is 2, what is your y? When x is 2, what is your y? When x is 2, what is your y? Okay, that means we are checking the error for this point, only for this point. Okay, so the formula, okay, the formula is given in the slide for the true percent relative error. Okay, true percent relative error, where you need to find for the true value and the approximate value. So what is true value? What is true value? True value is. What is true value? You have to substitute the x into here, right? Because this is the exact solution. Then you will get a value in 4 decimal places. That is the true value. And this one, y4, this is the approximate value. This is the approximate, and what you obtain here is the true value. So you substitute these two into the formula, okay, in the slide. Okay, we use the true value minus the approximate value divided by the true value times 100%. Okay, then you get the percentage of the true percent relative error. Okay, true percent relative error. Okay, this one you can try. Okay, try to work this out. So if you want to see the complete solution working, you can refer to the video of section 1. Okay, video of section 1. That's made yesterday. Not section 2, sorry, section 2. The video of yesterday. Section 2, week 2, lecture 2. But I think this one is enough for you because you have already know how to find the K1, K2. So you just try and check. Okay, so if there are any issue or problems, you can discuss it in the next class. Okay, so today I have to stop here. I'm so sorry. I have to end the class earlier. Okay, so I will see you next week.